everyone, and welcome to Chronos Lumen. This is where time meets light, where we uncover the hidden stories of people who changed the world but were forgotten by it. Every great invention, every discovery we celebrate, hides the name of someone who worked in silence. Today, I want to tell you about one such person. A woman who captured the image that revealed the secret of life itself, but never received the credit she deserved. Her name was Rosalind Franklin. And this is her story. It's London, 1950. The world is still recovering from the devastation of World War II. Science is moving fast, every discovery feels like a victory for humanity. Deep inside King's College, in a dimly lit basement, a young scientist stands beside a large X-ray camera. The machine hums quietly as she carefully adjusts a small sample, strands of DNA, the molecule of life. Her name is Rosalind Franklin. And at that moment, she doesn't know that her work will soon unlock one of the greatest secrets in biology. But she's not working for fame or recognition. She's working for truth. The truth hidden in the smallest structures of existence, atoms, crystals, and light. In that cold, underground lab, she was studying the building blocks of life. And unknowingly, changing history. Rosalind wasn't like most scientists of her time. In the 1950s, science was still a man's world. Women were rarely seen in research, and when they were often ignored or undervalued. But Rosalind, she didn't care about that. She was focused, disciplined, and incredibly sharp. She had already earned her PhD at just 26. She'd studied the structure of coal and graphite, work that later helped build stronger materials and even improve gas masks during the war. She wasn't just a female scientist. She was a scientist, period, one of the best in her field. When she joined King's College, her goal was clear: to discover the physical structure of DNA. She wanted to understand how life stores and transfers information. And so, she turned to her greatest tool, X-ray crystallography. A technique that captures how X-rays scatter when they pass through molecules. From those patterns, she could calculate the shape of the molecule itself. Imagine it. Invisible beams of light, bouncing off the secrets of life. And one woman decoding them by hand. Months turned into years. Rosalind worked with incredible precision, taking photographs of DNA fibers from every possible angle. Then one day, it happened. A new image appeared on her photographic film. A perfect X shape of dots, glowing faintly on the dark background. That image was labeled Photo 51. It was the clearest picture of DNA ever taken. A silent masterpiece that revealed, for the very first time, that DNA was not a simple chain, but a double helix. Two spirals, intertwined, carrying the instructions for all life on Earth. That one photograph changed everything. It was, quite literally, the picture of life itself. But history had other plans for it. Rosalind didn't publish the photo right away. She wanted to be certain, she wanted more data, more measurements. But while she was working, her colleague Maurice Wilkins, who misunderstood their partnership, showed Photo 51 to two other scientists without her permission. Their names? James Watson and Francis Crick. When they saw that image, they knew instantly what it meant. It was the missing piece of the puzzle they had been struggling with. Using Rosalind's data, they built a physical model of the DNA molecule. They published their findings in Nature in 1953, and it made them famous overnight. Watson, Crick and Wilkins later received the Nobel Prize for discovering the structure of DNA. But Rosalind Franklin's name was barely mentioned. The photograph that made it all possible, her photograph, was used without her consent. She had given the world the key to life. But history closed the door on her. Still, Rosalind didn't stop. She moved on to another lab, continuing her research on viruses, carbon, and molecular structures. Her colleagues said she was kind, determined, and deeply curious. Always questioning, always learning. But years of exposure to X-rays had taken a toll on her health. She began to feel weak, exhausted, and ill. Even as cancer spread through her body, she kept working. She published groundbreaking papers on the structure of the tobacco mosaic virus, research that would later help fight many diseases. On April 16, 1958, Rosalind Franklin passed away. She was only 37 years old. She never knew that her photograph had led to a Nobel Prize. Because by the time the world celebrated DNA, she was already gone. For years, she was a footnote in textbooks, the assistant, the technician, the woman who helped. But slowly, scientists and historians began to dig deeper. They found her notes, her letters, her lab books. And they realized the truth. She was not a helper. She was a pioneer. Without her photograph, the structure of DNA might have remained unknown for decades. Today, her name stands beside the greatest in science. Institutions, scholarships, and laboratories around the world now honor Rosalind Franklin. Her legacy inspires young scientists, especially women, to stand strong, even in the face of doubt. Rosalind Franklin's story teaches us something timeless. That recognition may fade, but truth endures. That light can be stolen for a while, but never extinguished. Every discovery carries a story. And every story deserves its light. Thank you for watching Chronos Lumen, where we bring the forgotten brilliance of the past into the light of today. If this story moved you, subscribe, share, and join me as we uncover more untold stories of history's hidden heroes.